Alright, so we have a plane flying with a constant speed of 360 kilometers per hour, passes over a ground radar station at an altitude of 1 kilometer, and climbs at a rate at an angle of 30 degrees. At what rate in kilometers per hour is the distance from the plane to the radar station increasing a minute later? Round your answer to the nearest whole number. Okay, so first of all, the distance is going to be this amount right there, and it is at a 30-degree angle right there, then, and this is 90 degrees, then this whole angle there is 90 plus 30, or 120 degrees. And we know that it is moving at 360 kilometers per hour. And what we're trying to find, at what rate is the distance. So we're trying to find the rate of change of the distance. So at what particular time? A minute later. So 1 minute is 1 over 60 hours. And we know that this, okay, so the distance on this side, we're traveling at 360 kilometers per hour. So what will this distance be at a given time? Well, let's think about this. If we're traveling at 360 kilometers per hour, what would that distance be after 1 hour? If you're going 360 kilometers per hour, after 1 hour, it would be 360 kilometers. What about after 2 hours? Well, after 2 hours, you'd go twice that far, or that would be 720 kilometers. What about in half an hour? Well, in half an hour, you'd be at 180 kilometers. So the distance you go depends on how much time you've been flying. And so in general, your distance equals your velocity times your time. And so the distance on this side, the distance from here to here, is going to be 360 times t. Now, here is the part that you probably don't remember, but from trigonometry, the law of cosines, if I have A, B, C, and this angle is capital C, that's supposed to be a B, little c squared equals a squared plus b squared minus 2ab cosine capital C. And so in this particular example, our c squared, that's our distance, that's this side right here, equals the other two sides. So remember the law of cosine says you have two sides and the angle between them. Then the third side, that's your c. So you have a, b, and c. So two sides and the angle between them. C squared equals 1 squared plus the other side is 360t. 360t squared minus 2 times 1 times 360t times the cosine of the angle between those two, which we said was 120. And so c squared equals 1 plus 360 squared, I don't know what it is, 360 squared t squared minus 2 times 360 is 720t times the cosine of 120. So the cosine of 120, so 120, that would be pi over 3 family, and so I believe that would be -1/2 cosine of 120. Make sure I get that right. That should definitely be right. And then now I want to take the derivative, and that will, and I want to get the related rates. I take the derivative with respect to time. So let me check this real quick here. In degrees. -1/2. Okay, so I take the derivative. That'll be 2c times c prime, because if I take the derivative, I'm taking the derivative with respect to time, so anytime I take the derivative of something that's not time, I have to follow it with a prime, equals derivative of 1 is 0, derivative of 360 squared t squared is 2 times 360 squared t, and then this was -720 times -1/2, so that would have been plus 360t. When I take the derivative of that, I get plus 360. And now I need to plug in, I'll be like 1 minute. And now I need to plug in 1/60th for the time. So 2c times c prime equals 2 times 360 squared times 1/60th plus 360. And I need to solve for c prime. C prime is what I'm looking for. So I still have that 2c I have to solve for, and that 2c I'm going to solve for it by filling in this triangle 1 and 360 times 1/60, and then that's c. And so you plug in 1/60 into this equation, and you solve for c, and you plug that c in there, and then you can get c prime. Okay, I have to go.